All right. Good morning, good afternoon, good evening to all of you AppSec engineers watching this from all over the globe. I think we've been waiting for this one. It's been a while since we did our last live stream, but hey, quality more than quantity, right? So obviously, I'm really happy to be here. I've been busy with prep for Black Hat. We are doing three courses at Black Hat, one on supply chain security, one on Purple Team AWS, and one on DevSecOps, which are really doing well. In fact, a lot of people have registered. If you are interested, you should think about this and look at if you are looking coming to Black Hat in Vegas this time. We're going to be there. We're going to even, in fact, AppSec Engineer is going to have a booth as well. You should check us out. Aside from that, of course, AppSec Engineer always wants to bring you amazing content, and this time it's no different. We're going to have a very interesting demonstration. We're going to have a conversation more than just a demonstration, right? Today, we're going to be talking to Rahul Jadhav, who is the head of engineering and the co founder of a company called Accuknox. Now, and first of all, am I shilling a company? Not really. We're looking at an interesting open source product that they have spearheaded into the community called KubeArmor. Now, I saw KubeArmor last week and I thought it was pretty cool because KubeArmor does things that makes my life as a Kubernetes administrator, especially from a Kubernetes security standpoint, a lot easier. And I myself have not tested it out much, but I'm going to do that live. So what we're going to do today is, first of all, Rahul is going to be coming on the show pretty quickly. And then we're going to be looking at some demos. He has some amazing demo setup. He does a great job of his demo set. He's going to look at different implementations of how KubeArmor can be used. And then he's going to walk me through it. I am a relative noob to KubeArmor. I have not done this before. So I'm going to deploy KubeArmor on my cluster, and we're going to explore KubeArmor on my horrible application that is extremely insecure in 1,000 different ways. So let's welcome Rahul to the stream. Hi, Rahul. Welcome to the stream.
Hey Abhay, hey everyone. Glad to be here. Nice to meet everyone here.
Awesome,
Hey,
awesome. We've already had quite a bit of people waiting. In fact, somebody said, "Good morning, everyone. Nice to see all of you waiting on the show. It's really nice to see." And of course, we'll be taking questions all along. You can just place your comments, start posting your comments whenever you're interested, and I'll be sure to pass it on to Rahul. Now, Rahul, first of all, tell us a little bit about yourself. Tell us a little bit about KubeArmor. Tell us about Accuknox. Tell us about this whole system that we have here today.
yeah. I'm Rahul Jadhav. Even though I'm a co-founder of Accuknox, development has always been my passion. I'm one of the. I've been a kernel developer in my past organizations. Uh, I've been primarily working on network and transport optimization. Uh, Security always comes with it. So security has always been a focus for me. Uh, when we started talking about Accuknox, there was a different focus altogether. So we were trying to check what kind of security elements are we missing today, and we thought which is the natural place to go. We saw certain frameworks out there which can explain you what are the techniques, tactics that an attacker could possibly make use of, and that's how we basically conceptualize the idea about what we need to do. So it's been fun to work on that journey, and I'd love to share with this community here as to how we went ahead on that aspect.
Awesome. Now, I think we need to start with where the rubber meets the road, Rahul. I think everybody is interested to see the demos, look at what KubeArmor is. So, really, what was the kind of, what is the motivation behind KubeArmor and why did KubeArmor actually come to be?
Yeah, I would like to quote one specific incident that happened. When we had just started working on different components of Accuknox. Uh, any security company would try to check what are the attack vectors or attack parameters that are exposed out there in the systems that you want to protect. And MITRE TTPs sort of stood apart from for us. We had a look into MITRE TTPs, and then we checked out all the existing security solutions out there. When anyone talked about runtime security, what they meant was how do you protect your pods, your Kubernetes from the networking aspect, like how would you stop the attacker from getting inside. uh, but then when we looked at the MITRE TTPs, we saw that there's so many other aspects of defensive techniques or attacking techniques that are prevalent, which cannot be really undertaken, which cannot be handled by a network standpoint alone. And then we saw that the other tools which can give you observability of lot of those aspects, like if a particular sensitive data store is accessed, or if certain system event happens, you get observability. But when we checked into MITRE TTPs in detail, there were certain mitigation techniques, some basic mitigation techniques, which could be very easily implemented. But we don't today have a system to enforce that kind of policy. So that's how we started. We thought, okay, let's do one quick prototype. Does it make sense? What are the existing things available already in the context? Traditionally, for decades, we have been making use of something called as Linux security modules like AppArmor and SLNX to protect such from such kind of things. Can they be practically be made use in the context of Kubernetes? That is the first thing that we thought. That immediately, when we saw the mitigation aspects in the MITRE TTPs, that thought came to our mind. Can we actually use SLNX and AppArmor profiles directly with Kubernetes? And there was a way to actually use. There is a way already today to use SLNX and AppArmor profiles in the context of Kubernetes workloads. But then you have to, as an administrator, you have to understand how to create a SLNX policy or an AppArmor policy, and it is
Which
immensely
is not
difficult.
easy. Yeah.
It's
Yeah.
immensely. I mean, the complexity actually is counterproductive, because you might end up opening holes in your system rather than fixing it. And that was
Yeah.
quite a
False
shock
sense
for
of
us.
security, right? Yeah. It introduces
Exactly,
a massive false sense of security sometimes, even though, yeah,
exactly.
I get what you're saying.
So at that particular point in time, we thought, okay, is it possible for us to make it any simpler? We certainly thought that it is impossible for any individual system administrator to learn both AppArmor and SLNX and to enforce
Yes.
policies on the applications which are changing on a weekly basis or a bi-weekly basis, let's say. It's an impossible task, right? So that's when we envisaged, conceptualized, KubeArmor. Can we automate that process? Can we have a policy engine which can make life simpler for these security administrators who might want to put a simple rule, but they are not very familiar with AppArmor and SLNX? And I'm calling on AppArmor and SLNX both because in cloud providers world today, both of them gets used. It's so, for example,
Yeah.
today GKE by default supports AppArmor, whereas AWS by default supports SLNX, and there are
Mhm.
new families of LSMs coming up. Like we have BPF LSM, which is a new emerging LSM that KubeArmor integrates with today. Just today we announced
Mhm.
that support. We had version
Oh,
3.5 release today. So the point is that there are security primitives available, extremely difficult to use on the host side itself, and then it's a straight up comatose. If we have to use it in the context of Kubernetes, uh,
yeah.
that's where the whole idea about KubeArmor came into place. And it's not like we have talked to a lot of industry forums. In fact, there was one particular advisor I would like to Suchakra Sharma gave us a first hand information as to what kind of problems he faced, and so there were a lot of discussions, and then we decided to build a prototype, check whether some of our hypotheses can actually work. We saw that it works, and we then converted it to a proper policy enforcement engine on top of Kubernetes.
Awesome. That's great. I'm actually really excited to see what you have for us today in terms of a demo. So if you'd want to get started, this would be a perfect time. I think our viewers are aching for a demo. And then, of course, they're going to watch me kind of flub through my own demo, which I'm going to be needing your help in terms of. So let's get started. Rahul, if you are ready with your demo and your whatever you want to present to us, we are good to go. You
Okay,
can. Yeah.
Yeah. So before I go into the demo, maybe I can present some basic things. One thing that I would like to present about, is when I say about runtime security, and like I said before, when folks used to talk about runtime security, they primarily used to think about networking aspect, right? And we
Mm-hmm.
have a MITRE attack navigator here, which
Mm-hmm.
basically shows you all the different TTPs in the context of network. So I've just enabled network here as of now, and you see all these different TTPs that are enabled. Now,
Right.
when it comes to systems, there are two more other platforms that needs to be enabled: the Linux and containers. So the moment I enable Linux, you see all the TTPs that are enabled here. So
Yeah. Yeah.
essentially, what we have been focusing on for these many years is protecting from the network aspects. But today, with supply chain risks, uh, attacker has multiple, more than one ways to get into your workloads. There are multiple ways,
Right.
that an attacker. There
Right.
could it could be a 0 day. It could be a known vulnerability which you might not have patched. Uh,
Mm-hmm.
so the premise starts from where usually if you're protecting something, you should make a assumption that attacker is going to get into your system. How do you protect from
Right.
there onwards? So this is just one specific action item. Again, containers add up to certain things, but Linux and containers put together is primarily the most of the stuff. The networking aspect is just one aspect of this, even though it is important.
Right.
It is important, of course, but there is a wider aspect that needs to be taken care of, and that's where
And it doesn't help
KubeArmor.
with all the Linux kernel exploits that we've been seeing as well, right? I'm sure that also plays a pretty big role with some of the
Exactly,
stuff
exactly.
that can
In a
happen
way,
in this space.
in a way, 2021 had been a big eye opener for most of us here. Most of the attacks that have happened in 2021, in fact, in December, a lot of folks, Christmas got screwed because of it. The Log4j attack.
Yeah,
Then attacker could make use of that vulnerability, insert their payload into Apache workloads, and then attack the credentials, do lateral movements. Basically, how do you protect from this is what KubeArmor is all about. In fact, we didn't have to convince users after 2021 because they have already seen what's happening out there in the real attacks. So, so, uh,
absolutely.
so, yeah. So, talking about KubeArmor, the problem statement I've already mentioned. Uh, how do you protect your pods from within? That's the first aspect of KubeArmor. You have Kubernetes, which has an execution unit, which is a pod. But within the pod, you have several containers, and within those containers, you have several binaries. So how do you, you make an assumption that out of all those binaries, and because of that attack surface that is exposed, you will end up with a vulnerability which is either known or unknown to you. So make an assumption that the attacker is going to get into your system. How do you protect? What are the file system accesses that can be that can be prevented? Sensitive file system accesses that can be protected. Which are the different processes that can be limited from execution? And what are the different kernel capabilities or network accesses? Even the network access. A lot of times, what happens is within your pod there would be only 2 or 3 binaries which are allowed to communicate to the outside world. But because of this notion of pod being an execution unit, the whole all the processes within that pod either gets egress access enabled, which which
Hmm.
which by itself is a problem. So how do you limit that constraint? So zero trust, some of the aspects of zero trust, which means having a least permissive policy settings, is something that you can bring to life with KubeArmor at a very granular level. And some of the problem statement that we had to tackle along the way route is, some of the Linux kernel primitives are not tailored to Kubernetes platforms. Like I said before, your container runtime security is not necessarily equal to network security. Of course, network security is one of the important aspect, but then system security or application security is another aspect, and data security is another aspect. So all these runtime issues needs to be tackled. Here is a sample depiction. What I've mentioned here is this is a pod. There are these 2 pods. Now, Kubernetes by itself, as a control plane elements, inserts certain credentials into the pods, like the Kubernetes service account token. And again, I'm going to show you subsequently a demo on how to protect these kind of elements. So the Kubernetes service account token is mounted within the pod, and all the containers, all the binaries within the containers have equal access to these service account tokens. If you see any attack in Kubernetes, you just Google for attacking Kubernetes. At some point in time, once the attacker manages to get inside the Kubernetes pods, the first thing that they're going to look for is where are the service account tokens located. They get the service account tokens to do the lateral movements. Basically, once you have the service account token, they can connect to the API server, get more information, and then do lateral movements.
Right.
It's a real pain today. And service account token typically within the pod is accessed by a single binary or two binaries, maybe one or two binaries. But then it is
Yeah.
because of this notion of execution unit being a pod, it's exposed to everything.
And
The
it's a
same applies.
binary
Yeah.
solution. For instance, a lot of people just say, hey, you can turn off service account token by using auto mount service account. But the thing is, a lot of pods might need it to access things like secrets or access other Kubernetes resources. So it's not always possible for you to, hey, just turn off service account token. You might still need it, but you might need to still protect it. So there may
Correct.
be those edge cases that come up quite a bit as well, right?
Absolutely good point. So what you're saying is there are valid reasons for an application or a workload to use service account token to connect to the Kubernetes API server. Yes,
Yeah.
the point is, how do you enable only that application within the whole pod, or that particular process within the whole pod, to have access to that service account token and no one else? That's the key
Right.
point here, right? And that's about the control plane security. You also have
Mhm.
workloads which internally might have sensitive information, you have MySQL databases where the first thing that attacker is going to do is uh, exfiltrate the data, the raw tables from your MySQL databases. So how do you protect that? That is also an open-ended question today. So KubeArmor basically helps you protect from those aspects. I'm
Right.
going to skim through these slides pretty quickly. I don't want to get into individual slides. This I've already talked about. Systems primitives. This is another important point I would like to talk about. What is the technology that we use inside KubeArmor and how we ended up with that? There are multiple ways, there are multiple approaches to handling to do enforcement. I've seen enforcement by making use of techniques such as ptrace, by
Mhm.
making use of ld preload. uh, these
Mhm.
techniques cannot scale. Recently I've came across a solution which makes use of glibc. It replaces the glibc within the container to its own version of glibc, so that it gets a handle on different system calls and different library calls that have been made. These approaches
Right.
are not necessarily a better approaches, because it changes the integrity of your container image. uh, you don't want to make any changes within the container images, because the integrity is going to be changing. You don't want to introduce any new drift within the container images.
Right.
That too. So with KubeArmor, what we decided, we need a mechanism which does not require you to make changes within the container image or within the pod. It should be a completely transparent solution. And of course, LSMs quickly stood apart for us, LSM based security, because for decades this kind of security has been made use of in the host context, where you don't have to change the SDKs or the binaries to protect your host workloads. The question for us was, is it possible for us to use the same primitives in the context of containerized workloads, or even better, orchestrated containerized workloads, Kubernetes orchestrated.
Right.
So each of these approaches has its own pros and cons. We decided on two approaches. One is using LSMs for policy enforcement purpose, and on the auditing aspect or telemetry aspect, we decided on making use of eBPF. So today, or traditionally, in the host based protection, host based systems, audit was one of the popular kernel primitive that was being made use of, but it does not really scale. It has a lot of issues in certain cloud provider space. those primitives are not enabled by default. Like in case of GKE, that is not available. GKE container optimized OS, it is not enabled by default. So you have a lot of issues there. So we decided on making use of eBPF for getting the observability feeds and auditing the systems in general. So those were the two critical decisions that we took early on that actually made our life simpler in terms of deployment efforts of Cuba. There's one more point I would like to talk about, about enforcement part, which is there is something, lot of systems, they provide enforcement in a reactive way, which means that if you get an event, if that event sends, if that event's result, if it's a sensitive event, ideally that event should not have happened. Let's say it's open to a sensitive file. Ideally, you don't want
Right.
someone to access that sensitive file. You want to kill that process. So what a lot of engines do is that they reactively go and kill the process. But by the time the process is killed, the damage might have been already done. So post exploitation mitigation. There is a typical term used here. I came across this term very recently. Post exploitation mitigation is something which is not of a value for enforcement system. If you have an enforcement system, it should be doing inline mitigation, which means that before the attack happens, you should be able to stop the attack. Before the access happens, before the process is spawned, you should be able to stop that spawning event itself. So that's where inline controls from LSMs helps us out, helps KubeArmor.
Right. So is that where the eBPF hook part of it comes into the picture? Is that the inline?
eBPF, in case of KubeArmor, eBPF is made use of primarily for auditing and observability purpose. For policy enforcement, we still make use of AppArmor and SC Linux and BPF LSMs from today onwards. Just we have announced version 0.5, which is making use of BPF LSM. Previously, BPF LSM used to be called as KRSI. That was a Google term, but now it's been replaced with BPF LSM. So but yeah, for enforcement side, LSM has been made use of. For observability and auditing purpose, eBPF has been made use of. And I would now say that because of BPF LSM, eBPF has sort of now moved into the enforcement aspect as well. So we can see already how the ecosystem is maturing.
No, that was the reason I brought up that as the hook part of it, because I thought maybe that's the reason. Maybe perhaps you will start using that as the enforcement engine over time as well, as that gets more popular, perhaps.
Absolutely, and you made a point already. We released a blog today saying if there is AppArmor and BPF LSM available today, what to make use of. So we have decided to go by default with BPF LSM because of certain reasons. So we can already see that it's gaining popularity because of the flexibility it provides.
Yeah. No, it's pretty powerful stuff. So I can imagine that will be the way to go in a few, hopefully months, but maybe a few years. Yeah.
Absolutely. Now let's get into the brass tacks, shall we? Now I would like to talk about the demo. So we have a demo scenario here, which is a typical deployment. You have WordPress application and MySQL database that has been made use of this WordPress application. And when we deployed this application, we tried to see what are the protections that we can provide for these applications. MySQL today keeps all its tables information, raw tables in a particular path. An attacker could make use of that path and exfiltrate the raw tables as it is outside, or a ransomware could go and encrypt those specific tables once they gets into that particular pod. So this is the database path. Now the first scenario is how do you audit the sensitive paths? Even though I'm calling it audit here, out of this 4 scenario, this is the only audit policy. You can as well have block policy here. So apart from MySQL process, no one else should be able to write into this database path recursively. There is a recursive flag. So folders and subfolders included.
Oh, nice. That's important, right? Because the process talking to the to write things into that path. That's a very important distinction.
Exactly. In that particular pod, apart from MySQL and maybe a few other processes like MySQL dump, no one
Yeah,
needs access to that particular path, right? Uh,
precisely, exactly.
yeah, and even if apart from MySQL anyone tries to access that, the least you can do is audit it so that you know what who's been accessing that. The least you can do. Uh, the other aspect is how do you protect sensitive files? We found that in the case of WordPress, there is a file called as wp-config.php, which already has some authentication tokens kept in within it. So this file is typically accessed only by the Apache process within WordPress. So how do you make sure that apart from that process, no one else has access to this particular WordPress configuration file? These two are aspects about protecting your workload's sensitive data. The third aspect is about how do you protect the control plane security tokens. Immediately, what comes to mind is service account token. How do you block access to Kubernetes API server by blocking access to
Mm.
Kubernetes service account token? So that's the third use case here. The fourth use case is again an important one. A lot of times, what happens is you have container images which gets added. There are certain binaries that gets added to these container images so that they can be used during maintenance mode, or in
Right,
staging environment the user might or the developer might want to use those binaries. But since it's a container image, the same container image gets passed on to the production environment, but there you don't have any control. The same binary could be used by an attacker, could be exploited by an attacker to gain footholds into the workload. The fourth aspect here is in case of WordPress application here, by default, apt and apt-get, these are the package management tools that are shipped along with the WordPress application. So typically, you should not be making use of apt-get in the production environment because it induces drift. It will introduce drift. It will add new binaries into the system paths and increase the attack surface. So you don't want ideally users to use that kind of binaries in the production environment. So for these four use cases, you see these are the four KubeArmor demo policies, and you see how simple it looks like. The first thing that you should take a note of is the kind. So all these policies are kept internally as a Kubernetes resources, CRDs. So KubeArmor
right,
policy is a resource which can do protection at the pod level and internally at the container
right,
level. We also have something called as KubeArmor host policy, which can protect the worker nodes as well. So protecting the pods as well as worker nodes is possible. The first policy is about auditing access to this particular folder. The second policy is, like I mentioned, the wp-config.php has to be protected from, it needs to be blocked access. Similar, the service account token. So you see the first policy is the audit policy. All the other three policies are block policy. Service account token, blocking access to service account token. And the next aspect is blocking access or execution uh, or limiting execution of certain binaries like apt and apt-get at runtime. So these are the four
right.
policies that immediately map to MITRE ATT&CK TTPs. And there are certain other compliance reasons as well because of which you need to have control over this binary, these aspects. Next, I'm going to move into the CLI mode of demo where I can show you actual enforcement. So what I have here is I have three windows. This is the Kubernetes. It shows what are all the pods and workloads that are running. You can see the KubeArmor is installed as a daemon set. I
Mm-hmm.
have the WordPress and MySQL application running here. This is any alerts or telemetry that is emitted out by KubeArmor. We have a KArmor CLI tool which can get
Yeah,
this kind of alerts and information. And I have the security policies here, and I'll exec into the workloads using from here. So first, I'll first check whether there are any. Oh, I already have a policy. Maybe I'll just delete it. Okay, so I already have a policy which is applied, which is auditing MySQL folder, a specific folder within
right.
MySQL. What I'll do is now I'll exec into MySQL, and then I'll try to do touch into that particular folder path. Awesome. So you see, I did because it's an audit policy. You can see that the
Mm-hmm.
action is audit and the enforcer is eBPF monitor, and you see all the corresponding elements of the event. Like, not only the kernel event by itself has been passed, but you also get all the associated Kubernetes and container metadata. You have the namespace name, pod name, labels associated with that workload, container ID, container name, container image details. And you also see the policy name in the context of which this event was raised. I can very easily uh, convert this policy into a block policy. I can quickly change it to block. Now I have changed this to block policy. Now if I exec into the pod again and try to do a touch with, let's say, ABC, you see the permission is denied. Now the action is blocked. The result is permission denied. You are not allowed to create any files from any other process outside of MySQL inside this particular pod. Very simple
So that's what I
policy.
liked about this especially. I mean, aside from the policy, which is very easy to compose, I like the fact that the gRPC log streaming is really useful because you can probably even set it up as a behavioral system and learn what's happening to your applications at runtime, and then probably use that for enforcing policies based on what you learn over a course of, let's say, a week, a month, whatever, right?
Brilliant. Actually, that's a brilliant point, Abhay. We there is a system out there which integrates with KubeArmor, and it's called a
Yeah.
discovery engine. We call it discovery engine, which
Mm.
looks at these events, the telemetry events that are emitted by KubeArmor, and then auto
Yeah.
discover the security posture for those workloads. And these security postures are tailor made for that deployment, which means that if the
That's
same
awesome.
application is running in two different deployments, you might get different security posture, which is
Right.
specific to that particular deployment. So yeah, absolutely,
That's
that's completely
that's pretty
possible.
cool. Yeah,
Yeah.
that's
So
awesome.
I'll go into the other policy. So this is about blocking the WP config file. Now, before we
Mhm.
block this, let me just exec into the pod. So I have this PHP file, and in this PHP file, if you see, there are certain authentication tokens that are striven off. It's
Yeah.
not a good idea, but here we go. A lot of times there are
Hey, that's
precious.
WordPress. That's WordPress, right?
That's WordPress standard application. Yeah. Uh, you ideally you don't want to do that, but here we are.
Ideally, you don't want to run WordPress.
Yeah. Okay. So we have a policy which is now blocking access to that configuration file. Now, if I go ahead and now try to access the configuration file through some other process, it gets blocked. So you see, there is a permission denied. It shows you the context in which what has happened. It gives you an absolute path for that particular file, so that you can base your decisions directly on the file paths. It gives you the policy context and everything. The best part is you remove this policy, and again, obviously things start working for you. So this mode, a lot
Yeah.
of times what happens is you might want to enable full access for a certain duration for a maintenance time
Right.
frame window.
Right.
So now you can limit 90% of binaries, execution of these binaries or access to the sensitive file paths, but enable it during certain maintenance periods where all the
Right.
external access is turned off. So that was one of the use cases that was quoted to us in return. We were not aware of this kind of behavior or use case. Now the next aspect is about service account token. Now we have WordPress application again, and the service account token. If I can cat the service account token, I can use curl. I use that service account token and reach the Kubernetes API server and pull the information. So I'm able to pull the information
Right.
from Kubernetes API server using the service account token. Now I want to block access to that service account token. I have this policy here. Now I log into the WordPress application and I try to do a cat. Obviously, the permission is denied. I try to do a curl. and now you see unauthorized here. So now, apart from WordPress application, no one else would be allowed to make use of the service account token. That's the beauty of
Right.
this policy. The
Can we
last
take
one
a
is
look at that policy, the block essay policy, if you don't mind? For
yeah,
this.
yeah. Okay, so let me
So that,
just
yeah. So what we're doing here is a KubeArmor policy that is, so you're doing a match label on the app label of WordPress, and
correct,
then you're of course. So this is namespaced, I'm guessing, right? So this policy is going to be
correct.
applied within that namespace. Okay, that's
Yeah.
cool. Um, and the so the spec. What does the severity indicate? What does severity 7 mean?
So severity is a construct that KubeArmor has added. So a lot of times you want
Hmm.
different levels of severity, right? So there is something called as
Okay,
you can have severity on the level of 1 to 10,
right.
and you can define your own severity as well. It's basically left up to the user.
So it's
We
kind of like
also have
metadata for the
data
block
for
or
the
the
person.
audit,
How critical that information is, if
right?
eventually this information, if you see this severity here, right, that severity gets passed on here, so that this
Right,
information can then be used by a SimSort tools to show on the SOC dashboard, that you have a severity 1 alert, a severity 7 alert.
right,
So you can accordingly give it a priority. So that's the whole point.
right.
Yeah,
All right. This is cool. So it says match directories, and then you are recursively matching those directories. So where are we
correct,
specifying the process name that is calling it in this case? I mean, you said that WordPress is the only thing that can call it. So where is
correct,
the
correct.
process?
So right now the process name is all right now, because in this
Mm-hmm.
particular workload there is no other process, there is
Mm-hmm.
no process which is requiring access to the service account. In this case
Okay.
we don't
Okay.
have anything, but what you can do is in real workloads you can have allow, you can have an
Mm-hmm.
allow policy, and then you specify from
Okay.
source, like you say from source, and
Oh,
then
okay. Yeah, that's
path
really cool. Yeah.
path slash user slash whatever the Apache file path is, and then only
Mm-hmm.
this path will have access to this, and apart from this process no one else can be allowed access to the
All right. Yeah. No, that's
to the
really
system.
useful. I think that's
Yeah,
that's going to be extremely useful for. So you're in this case you're allow listing it as opposed to deny listing it in the previous
correct,
case. So just by
correct,
converting that, you're doing that. Okay. Cool. So it's
exactly.
block, it's audit, and allow. So you have all three things. Okay.
Yes, yes. Allow is the primary thing which allows you to have least permissive policy settings. So zero trust posture you get with allow based policies, right? You know what your
Right.
behavior, application behavior is, and outside of that, you deny everything else. Yes. Thank you for bringing
So
up
this
that.
is a default deny until allow, right? So basically, you're saying as soon as you put an allow, the pod is isolated to the
Correct.
point of default deny on every other thing.
Yes.
Okay.
Yes. Yes.
Okay.
Yes. Exactly.
Yes. Okay.
And then we have an automated system to identify what should be allowed. Like in this case, if I do a discover, uh,
Mm-hmm.
this is a policy which is automatically created, which says that these are the
Mm-hmm.
action items that we have seen. This is the allow actions.
Right,
So
right, right. Okay, awesome. Yeah, okay.
the discovery engine creates automatically, understands your system's behavior, creates an allow policy based on that, and then everything else gets denied. You can specify deny or audit posture. In fact,
Mm-hmm.
KubeArmor has gone further, and you can have specific posture at specific namespace. One namespace can have audit as a default posture, which means that outside
Mm-hmm.
of allow, everything else is audited. Another namespace which has been running for, let's say, few months, and you're comfortable putting things into deny mode, that namespace
Mm-hmm.
can have deny posture by default deny posture. So it's
Okay.
lot of flexibility from the framework perspective.
Oh, nice. That's really useful, I think. As far
Exactly. I
as
mean,
I see.
we get users who say that I'm not comfortable. We are not comfortable putting things into deny mode, and we understand that.
Correct.
We have to live with that fact that the
Yeah,
same
no,
happened with
you can't break things, right? You wouldn't
exactly
have done profiling. It's not easy to just break things just by putting things in deny. So you have to have some kind of monitoring mode, behavioral analysis mode before you actually go ahead and even, or you may not even ever want to do deny. You might want to use audit and then improve the internal, harden the internal components if you need to, or do other things to make it a lot more secure. So yeah, I get that. It's completely
correct
understandable.
exactly. Yeah. So the last policy here is last policy is a simple one, but it's an important one because as simple as this, you put a simple policy saying match these paths and block these paths. So you have all your maintenance tools which you want to use only in a certain maintenance time frame. You put
Yeah.
all those maintenance tools here and you block deny access to it. And then so if I now exec into WordPress, run apt install, I can install any binaries because I have direct access
Right.
to app tools, dynamic package management tools. I apply
Mm-hmm.
this policy, k apply process, then exec into the pod. Now I run apt, it's permission denied, apt install, whatever. I mean, obviously the apt
Mm-hmm.
as well as apt get should be permission denied.
Mm-hmm.
You see the corresponding. Now you see the enforcer here is AppArmor.
Mm-hmm.
Earlier you
Okay.
might have seen when the audit event happened, the enforcer was eBPF monitor. So the monitoring was done by
Yes.
eBPF,
Yes. Yes.
but the enforcement
Right.
is actually done by AppArmor here.
Right.
So now
Right.
with BPF LSM, we have BPF LSM and SC Linux as enforcers as well.
Oh, nice.
So
Yeah. So yeah, this makes, I think, AppArmor the need to write AppArmor policies and understand that pretty much not required, right? Because you don't need to figure out what is the AppArmor policy, but where you can write KubeArmor security policy, and that's probably a lot more easier in
exactly,
terms of
exactly.
the ability to triangulate specific events.
Exactly. So the,
Makes a
the
lot of
aim
sense.
here is that internally KubeArmor is converting this Kubernetes this YAMLs into corresponding AppArmor
Hmm.
profiles today and
Right,
making
of
use of
course.
that. But
Hmm.
you have this whole ecosystem to identify the event, map it to the corresponding policy, map it to the corresponding Kubernetes metadata and container metadata. So that all that requires that is where we have spent a lot of effort.
Nice, awesome.
Yeah.
This is great.
Yeah, so that's the demo. And the one important point, like I mentioned before, a lot of times it's not easy to write these policies. Some of the
Right,
policies you can write, some few of the things you want to block by default. Those are the easy
right.
things. And KubeArmor also has something called as policy templates.
Hmm.
So here you'll get a community curated list of system and network policies. In fact, you'll see MITRE attack policies developed out of MITRE attack framework being mentioned here. There are
Hmm.
roughly like 350 policies here today for different workloads, for different compliance regimes, uh, available, ready to use policies available here. So this is recommended. This could be recommended policies. The other is discovering policies, which are allow policies, right? So that happens directly through the discovery engine. So both these aspects
Right,
are available, and all this is open sourced. KubeArmor today
right,
is a CNCF sandbox project. Uh,
right.
so that is one thing, that it's under CNCF governance. Uh,
Hmm.
we just happen to be uh, the maintainers of that project today.
Oh, nice. That's great. Right. If that's the demo, then I think I'm looking forward to diving in actually. So I've actually set up a Kubernetes cluster and I'm ready to go. So I'm gonna
Cool.
get started. And Rahul, you'll need to help me out if I'm going wrong somewhere. So
Mhm.
I've just set up a cluster and I'm actually gonna go ahead and figure it out like a complete noob. And I am. I'm not. I've done Kivano, I've done some other policy tools, but I've never done KubeArmor. So this is going to be interesting. So yeah, so I just have a pretty basic pod ready, which is a vulnerable app. In fact, I keep I keep joking around that after running AppSecEngineer and writing so many labs for AppSecEngineer, I'm an expert in writing vulnerable code more than secure code. So this
Hmm.
is a vulnerable app that actually is vulnerable to a YAML deserialization flaw. So for those of you
Okay.
who are not familiar with the YAML deserialization flaw, it's basically a flaw where somebody can send a crafted YAML, and that YAML, if it has code execution instructions, it actually executes that code in the backend on the backend platform, right? So in this case, if it's we are using a Python API, we are using a Python application that is processing YAML, and because of this processing YAML, if this and this is using a vulnerable YAML library, and as a result of which, what happens is that if I run some kind of YAML or craft some kind of YAML and get it to upload to this particular application, and if that YAML has some command injection payloads, it'll actually run those command injection payloads. So that's
Oh,
the
okay.
vulnerable app that I have here. So I have a cluster set up, and I am going to actually get started. So my cluster is, and I already have KubeArmor installed because I installed it through the KArmor CLI.
CLI to
So
to
yeah, so I just use KArmor install, and this is what I have running. This is basically, and I have Cilium. I'm guessing Cilium is required from the network policy eBPF standpoint. I'm not sure. Is
No,
that a
no,
requirement?
no, no. There's no such requirement as such. It just happens that me and my team are more comfortable with Celium. It
Oh, okay.
happens to be the CNF our choice, but the KubeArmor does not depend upon any specific CNI underlying CNI. Yeah.
Right. So I'm using a K3s cluster on the cloud. Basically, I'm using a K3s cluster on the cloud, which is from Civo. I really like them because they're K3s, so it's kind of easy to work with. It's pretty fast. Now I am going to deploy this app, and then I'm going to start. We're going to start locking it down. Right. We're going to
Okay.
start locking it down. We're going to do some interesting things with it.
So,
So
but before
kubectl.
going into the details, but let me ask you this: is that a deployment or an individual pod?
This is a pod.
This is the pod, right? So pod. So what KubeArmor does is it identifies deployments and then patches those
Okay.
deployment with certain annotations. So unless and
Okay.
until you have a deployment, but today we have made a release in KubeArmor which allows you to have even enforcement at the pod level. But that release you might not have. So you need to use a deployment to
Oh, okay. I am not sure
let
if
me
I do have it, but it actually enforced it. I actually ran something and it enforced it for me.
can we
So
check what is that? Can you do a describe of that particular pod? Yeah, let's see.
sure, I'm going to still deploy it yet. I mean, just
Okay,
I'm just deploying a pod. So
okay,
it's yeah, I'm running it in a namespace called PSP. It's going to create a service account and it's going to create my pod. My pod is called ironically
secure.
secure Flask.
Okay.
So, but it's not very secure. So
Yeah,
anyway, now let's actually go ahead and kubectl describe
that particular pod.
man,
Yeah.
my butterfingers. Describe pod secure flask on namespace PSP. So this is my pod, and yeah,
Can you go above in the annotation section? Annotation section. Yeah. Okay. So looks like it's a deployment. So you see the annotation is applied. The PSP
oh
Secure
yeah,
Flask. You see that AppArmor annotation is automatically applied by KubeArmor. Uh,
okay, that's
so
cool.
so Kubernetes requires that annotation to be applied before you start protecting that pod
Yeah, so
using
this would
AppArmor.
be required even for SecComp and AppArmor, right? So I'm guessing
Correct.
that is where that
Correct.
comes from.
Correct.
Awesome. So this is great. So let's get started. I actually have a very simple policy that I saw on your default one, which stops sleep, right? Stops me
Yeah.
from running sleep inside that particular or against the application to potentially bring it down, cause some kind of denial of service, right?
Correct.
So I'm going to actually start customizing this one policy to make it a little.
Sure.
So this is the policy that I did. I wrote the match labels. I've added the app, which is the label app and the value secure flask. Match paths is basically the path which has been sleep, right? So that's basically what I just used from your existing policy. I've not done much customization other than just the match labels bit
Match.
and of course the namespace bit as well. So now if we go ahead and do a kubectl apply -f stop sleep, then we should have, let's see. So now I have so it's kubectl get KSP, right?
Yes.
So if we, oh, sorry,
No, it's
not
part of
default
namespace, right?
namespace.
Yeah.
Yeah, yeah, yeah. My bad.
Yeah.
So if I do a describe, I'm sure I'll get a little more additional KSP, whatever this is, and KSP, right? So this should give me additional
Correct.
information. So this says, yeah, okay. So spec selector events. Okay, so this is, yeah, this gives me some information. Now let's go ahead and actually kubectl exec. I think I had run this command. Right. So this is my application. My application, like I said, is a is a Python application. Like you see, you have a whole bunch of things here, and this is using a vulnerable YAML instance. So in fact, if you see the I don't have autocomplete, so clearly,
Yeah. This is not Bash. Yeah. We all
yeah.
miss Bash.
So we have so we have PyYAML 3.12, which is the vulnerable version. So this is completely vulnerable. I've not fixed it in any way, right? Now let's try and run sleep, which is sleep 10, and I get permission denied as expected, which is great. Now let's actually start locking it down a bit more. Let's do an etc password block. Let's also do what would you recommend? What
So
would you think that we should do?
yeah, let's block access to /etc password file, passwd file, right? Yeah, that
All
that
right.
could be an easy target. So it's a file based rule.
Mm-hmm. So this will just change the
Name. Yeah.
ASP block etc, right? So this will
Correct.
be path slash etc.
etc
Shall we do a
slash.
recursive?
Uh, yeah, we can do recursive as well, but you don't want to block all the accesses to
Yeah,
all the
exactly.
binaries, right? So just we will do passwd. Yeah, and
Right.
then there is a
So
process. There is a construct called as process above, right? And this is a file.
right.
So you want to block access to a
Okay.
file. In the earlier case,
All right.
you're blocking access to process execution. So this
Process.
should be file. Yeah, yeah,
So this will be a file. So match
yeah.
path. So in this case, we are doing a selector and we're doing match paths and we're doing path etc password. All right. Let's
Simple as.
actually go ahead and deploy this. Apply. I hope I made the right change. Okay. Etc dot. Yeah. So now we have this, and I think we should now try and exec and do the same thing.
Yeah.
Cat at C pass WD, and voila, we've been able to successfully block access to this. Now let's see what is the LSB release to do our. Oh, this is not. Oh, it's probably not
Oh, within the it might be a.
Ubuntu. It's
Oh,
an
this is
Ubuntu,
Ubuntu.
so it's so it's apt get. So we have to block apt, right? So that's the process block that we're going to do on apt and apt get,
Yes.
I guess. So
Right.
so that we don't have people installing all kinds of naughty packages on our running pod. This again will take the same thing. I'm just going to copy paste it for speed. Don't copy paste things, guys. Uh, block apt. So I'm just going to make it block apt, and I'm going to say this is going to be a process, I'm guessing, right?
Correct. It's a process. Yeah.
So that would be bin apt.
Slash user bin apt. I guess. Let me just quickly
I
check.
can just do it here. It's fine.
Hmm.
Which
Yeah. Which app?
user
Yeah.
bin apt.
User
Okay.
bin apt.
Bin apt. Is that all? Is that apt get?
It,
Is that a separate binary?
yeah, it's a separate binary. Apt-get is a separate binary altogether.
Yeah. That's also right. Which apt get? Yeah. Perfect.
Yeah,
So
same.
we have this and we have the apt get. So we have both binaries that we don't want installing things. So now we deploy this as well. I'm doing apt. God. apply dash f apt YAML, and this is done too. So again, going back to exec apt update as well. Awesome. This is really useful. This is actually pretty quick because in less than what, 5 minutes,
Yeah, you
we've
can now
actually
plot.
made some pretty meaningful, meaningful security controls. Actually, this is not trivial in any sense of the term. So I think this is
Yeah.
really useful because I mean, I've struggled with AppArmor. I know that. I've struggled with AppArmor. I've struggled with. I've not even tried SE Linux. I'm like, this is horrible. SE Linux was like, oh my god, I'm not touching this again
No,
for as
if you
long as
just
I
want
can.
to check, but if you just want to check what kind of app armor profiles are created out of these policies, it's possible to check.
Yeah.
You can exec into KubeArmor and check the app armor profiles that are created. It looks so complex. It looks so
Why
complex.
not look at it?
Yeah,
Tell
let's
me
look
where
at
to
it.
check. Where do I go?
Can you exec into KubeArmor pod?
So I'll just do kubectl get pods in the kube system
Cube
namespace,
system.
right?
Yes, 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 yeah.
Okay. And which one? This one, the this pod.
Yeah, yeah, yeah. That's the pod.
Okay. Kubectl exec um, namespace cube system and IP this dash dash. Is it an sh or bash? I mean, what do I do? Sh
You
I
do
guess
a
should work,
bash.
right?
Yeah, SS should work. Also, it's better you do bash because you get completion, right?
Yeah,
I like
yeah,
the
it's a
completion.
little easier. All right. So where do you? I think it's in. Is it in?
Slash
Is it?
slash etc apparmor.d.
Oh yeah. Okay. So that
Uh,
is cd slash etc armor dot d. All
yeah.
right. Oh, okay.
So so here
This
you
is
see
got.
all the cube armor hyphen, right? So I'm not able to see your screen. There is some message that has popped up from one of our
Sorry.
user audience members. Yeah, great. Now I
Right.
can see. So
I
this
think
is
so.
this is
Okay.
the
Sorry.
yeah, no problems. So here we see the app armor profile. If you just cat this app armor profile, you'll see what the kind of profile internally CubeArmor has created to protect that particular.
Oh
Yeah.
wow. Okay.
So
Yeah. I
it
mean,
looks so
I'm
complex,
definitely.
right?
Yeah, it's a pain. Uh, this is something I'm definitely not writing. Uh,
Exactly.
I, if somebody tells me, I mean, yeah, it is definitely, it's not out of the ordinary. If you're familiar with Linux, obviously, you can most the policy start, policy end. At least most of it's pretty straightforward. But the thing is that the biggest thing that I feel that this gives you is the ability to roll out and roll back as a CRD, right? So I
Correct.
that's the big thing for me. That's my major focus. So I made a lot of sense because of that. Because as CRD, I can do it. I can store this as infrastructure as code. My entire, let's say I'm running 50 clusters. All the clusters I can start to deploy some baselines and get moving. And if you have already that you have your sample policies and you have your example policies, it makes life a lot easier. I saw that there was a whole bunch of Flask RC policies as well for Python and stuff like that. So I
Right.
think it's a great way to get started. I thought this is really useful. It makes a lot of sense as
Great.
far as and it's all open source, which is even easier because then you don't have to think about
Yeah.
paying for something that is potentially expensive. So it's something that is, and CNCF. It's is it a what kind of a license is it in terms of if companies want to use it? Is
No,
it
no.
an Apache or
CNCF.
what?
It's an Apache 2 license. It's a permissive
Okay,
license. A CNCF requires CNCF usually endorses those kind of licenses, which are permissive licenses for your project
right.
if they wanted to get it adopted as part of CNCF. So it's a
Oh, okay.
completely
No,
open license.
so even within organizations, somebody can use even the open source variant if they're getting started. So that's
Absolutely,
pretty good.
absolutely, absolutely. If you have a cluster or two, you want to just check
Yeah,
out. It's very easy to install. There is a KArmor CLI tool which makes things much easier to install, observe the
yeah,
logs, discover the
Yeah.
policies and things like that. Yeah.
Yeah, no, it makes a lot of sense. Absolutely. No, this is awesome, Rahul. I really enjoyed this. I mean, first of all, understanding, like I said, I'm a complete noob, but I was able to pretty much get up and running um, in
Cool.
less than few minutes. So I thought this was really easy, and I really like the kind of the tech that is behind it, especially the combination of the eBPF that's used for the audit piece and using LSMs for the actual enforcement and block and allow part of it. So I really like that. And I'm really looking forward to seeing what one can do with the BPF LSM as well, because I think that will really expand possibilities quite extensively. So it's really nice.
Absolutely, absolutely. We just got it released today. We made an announcement. We would really appreciate. We have a KubeArmor Slack channel, and again, all we engage with GSOC, we engage with the LFX programs to have contributors in KubeArmor. So if anyone is interested, we're really looking forward for having you
That's
on the
awesome.
KubeArmor community channel.
And one of the things that I'm going to be doing after this is probably building an AppSec engineer course on KubeArmor. We already have a pretty awesome set of Kubernetes courses on AppSec engineer. We have Kaverno, which is a product I'm sure you know very well,
Yes.
and we've done a lot of work in different aspects of Kubernetes security. So, yeah, if anyone's interested, we do a lot of classes on Kubernetes security at AppSec engineer. All you need is a subscription, and you can get started with all of this stuff. You get to play with hands-on labs like this, so it's really powerful stuff. So that is some I'm definitely going to be looking at this for our next course. It's really nice, and I think it's pretty powerful as to what you can do with it. So this is definitely going to be on my list of things to do. Right.
Great.
I think we have any questions from the. I think we had one question from the community, which I think Mr. Kashyap asked,
Yes.
can is there a way to send these logs to Elastic or Splunk? I think you can just stream those gRPC logs, right?
Yeah, you can obviously stream. The kubearmor APIs are available, but the best part is there is already a sample client available for Elastic and Splunk, which you can make use of
All right.
in the kubearmor GitHub repo, so as to simplify your task. Absolutely, it's available.
Looks like the KubeArmor community has thought of everything. That's awesome. That's nice
Yeah.
to see that you have thought of this stuff. I really thought that that was a very important use case because logs are
Yes.
typically the last thing people think about. And I think that's the first thing you should think about, because if you don't have observability into your security
Yes.
tools, and
Mm.
of course workloads, but security tools also, you don't really get that much value from those security tools. I think that makes a boatload
Absolutely.
of difference to have. Yeah,
Indeed.
so that's awesome. Thank you so much. So that's it for us. We're going to be ending the broadcast. Again, thank you so much, AppSec engineers, for logging in. And as always, if you are interested in learning all of this stuff, we're going to be doing a lot of private and public streams with people like Rahul, as well as, of course, you have access to our labs, which teach you all of the stuff from Kubernetes, AWS, AppSec, and more. So definitely check it out. AppSec Engineer is only a subscription away. And if you're at Black Hat, come and check out our booth. We're at Black Hat this time, and yeah, say hi to us, and let's give you some swag on the way out. So definitely check us out at Black Hat this time. Have a great rest of your day and have a good weekend that is upon us almost. So for me, this is the pre-kend. So for me, I check out on Friday. I don't like to do anything on Friday. So maybe my weekend is kind of already started. So have a great rest of your week and have a great weekend. Thank you so much, and thanks Rahul for being part of the show. I really enjoyed the deep dive, and I think CubeArmor was pretty awesome. So thanks so
Thank you
much.
for having me. Thank you for listening to us. Thank you very much. Have a great time.
Thanks. All right. Thank you very much, guys. And I'll see you in our next stream. Thank you very much. Bye bye.